this episode, we're going to get comfortable with a problem that sounds simple until you try to do it in real life, figuring out where sensitive data actually lives. Most beginners imagine sensitive data sitting neatly in a single database table with a clear label on it. But modern systems rarely behave that politely. Data gets copied, cached, exported, logged, and transformed, and those side effects create extra locations you did not intend. The goal here is consistency, which means you can repeat the same approach over and over and trust the results, rather than doing a one-time scavenger hunt. That consistency matters because you cannot protect what you cannot find, and you cannot prove you are protecting it if you do not know where it flows. By the end, you should have a clear mental model for how sensitive data shows up in storage, databases, logs, and even object metadata, and how to search for it without relying on luck. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with a clean definition of sensitive data so you know what you are hunting for, because searching without a target turns into noise fast. Sensitive data is information that could harm a person, an organization, or a mission if it is exposed, changed, or used in the wrong way. That includes obvious things like personal details, payment details, and health information, but it also includes credentials, secrets, internal system details, and business data that provides unfair advantage. The important beginner shift is realizing sensitivity is not only about what the data is, but also about how it can be abused in context. An internal employee directory might be harmless in one setting, but dangerous when combined with email addresses, job roles, and password reset patterns. Consistent discovery depends on agreeing on categories of sensitivity and then mapping those categories to recognizable patterns, fields, and workflows that leave evidence behind. Once you know what counts as sensitive, you need to understand why it ends up scattered across so many places. Systems rarely keep data in one single container because performance, reliability, and convenience encourage duplication. A file uploaded by a user might be stored in object storage, referenced in a database, indexed for search, and previewed in a cache, and each step can create another copy. Backups and replicas multiply that again, and temporary exports create short-lived copies that often live longer than expected. Even when developers do not intentionally copy data, automated processes like analytics pipelines and error reporting can pick up pieces and store them elsewhere. Consistent discovery means you assume sprawl by default, and you build a habit of looking for the same data in multiple forms, including raw, transformed, and summarized versions. A practical way to make discovery repeatable is to think in terms of data containers and data signals. Containers are the places data can live, like object storage, file shares, database tables, and log systems. Signals are the clues that sensitive data is present, like patterns that resemble a social security number, a credit card number, an access token, or an email address next to a name. If you treat every environment like a combination of containers and signals, you stop relying on memory or tribal knowledge. You also avoid the trap of searching only where you expect the data to be, which is exactly where attackers expect you to search, too. The method becomes: list containers, pick signals, scan for signals, confirm context, and record findings in a way you can repeat. The words list and method are not about making an outline. They are about building a mental loop you can run consistently every time. Storage is usually the first place beginners look, but it is also where the most surprising finds happen because storage tends to be flexible and loosely structured. Files can contain almost anything, and file names often lie, especially when people are moving fast. A spreadsheet named test might contain real customer records copied for troubleshooting, and a text file named notes might contain passwords pasted during an incident. The challenge is that storage does not give you neat columns, so you rely on content scanning and context clues like directory paths, owner tags, or access patterns. Consistency in storage discovery means you scan not only for obvious file types, but also for compressed archives, exported database dumps, and application-generated artifacts like reports. It also means you consider lifecycle areas like backups, snapshots, and temporary upload zones, because those are common places for forgotten copies to accumulate. Databases add structure, which helps, but they also add complexity because data can be spread across tables and joined only at query time. Sensitive data might be stored directly in a table, or it might be derived from other fields and only assembled in views. Developers sometimes store sensitive values in free text columns for convenience, like a notes field or a description field, which makes pattern-based discovery essential. Another common issue is shadow databases, like analytics stores or red replicas that contain the same data as production but are treated with less care. Consistent database discovery depends on understanding both schema and usage, because a column name like token can be harmless in one app and extremely sensitive in another. You want a repeatable approach that checks for known sensitive columns, scans for patterns in flexible fields, and then confirms whether the data is current, historical, or derived. Logs are the place where well-intentioned debugging can accidentally turn into a data breach, because logs are designed to be copied widely and kept for later review. Beginners often assume logs contain only technical messages, but logs can include user inputs, headers, identifiers, and error traces that reveal secrets. A single misconfigured logging statement can record passwords, session tokens, or full request bodies, and once that data is in logs, it may be shipped to multiple systems for searching and alerting. Consistent discovery in logs means you treat logging systems as high-risk data stores, not just as operational tools. You scan for sensitive patterns, but you also look for structural clues like fields labeled authorization, cookie, token, or password. The key idea is that logs are an echo of what the application sees. So if the application handles sensitive data, logs are always a suspect location until proven otherwise. Object metadata is easy to overlook because it feels like a label, not the content itself, but metadata can carry sensitive value in surprising ways. Metadata might include tags, custom attributes, or headers that describe an object, and those labels can accidentally reveal personal details or secrets. A developer might store a user email in metadata for convenience, or a workflow might attach a customer identifier as a tag for routing. Even when the metadata is not directly sensitive, it can create a roadmap that helps an attacker, such as revealing which objects belong to high-value customers or which records contain certain categories of data. Consistent discovery means you scan metadata the same way you scan content, looking for sensitive patterns and suspicious keys. It also means you treat metadata access rules as seriously as content access rules, because metadata is often readable even when content is not. To keep discovery consistent across all these places, you need a stable set of sensitive data patterns and a stable way to validate matches. Patterns are things like number formats, key prefixes, or recognizable structures that indicate a value might be sensitive. The danger is false positives, where random text looks like a credit card number or a harmless identifier looks like a token. That is why validation matters, because consistent discovery is not about generating the biggest list. It is about generating the most accurate list. You can validate by checking surrounding context, like nearby field names, file paths, or log keys that explain what the value actually represents. You can also validate by sampling responsibly, viewing only the minimum content needed to confirm what it is. The mindset is to prove to yourself that the match is real without turning discovery into unnecessary exposure. Another piece beginners miss is that sensitive data is often found through relationships, not just through pattern matching. You might not find a secret by scanning for a specific prefix, but you might find it because it sits next to the word key or because it appears in the same object set as configuration files. You might not find personal data by scanning for one exact format, but you can find it because you detect a repeated combination of first name, last name, and date of birth in a dataset. Consistency comes from combining two techniques: pattern-based discovery for obvious signals and context-based discovery for less obvious signals. The goal is not to become a detective every time. It is to build a repeatable habit of asking what else could indicate sensitivity even when the content does not scream it. That habit makes you less dependent on perfect patterns and more resilient against messy real-world data. You also need to account for data transformations, because sensitive data rarely stays in its original format. Identifiers get hashed, values get truncated, and fields get encoded for transport, and those changes can hide sensitivity from simple searches. For example, a token might appear base 64 encoded, or a personal identifier might be split across fields and recombined later. Even when encryption is used correctly, there can be plaintext copies in temporary processing locations, or there can be partial values that still carry risk. Consistent discovery means you look for the raw forms and the transformed forms, and you recognize the common places transformations happen, like exports, analytics pipelines, and application logs. You do not need to decode everything as a beginner, but you do need the awareness that the same sensitive value can exist in multiple shapes. That awareness prevents you from declaring victory just because you did not see the exact pattern you expected. Consistency is not only about finding data once. It is about being able to find it again next week after the system changes. That means you need a simple way to record what you found in terms of where it was, what type it was, why it was sensitive, and how confident you are in the finding. You also want to record what you did not scan and why, because gaps are part of reality and should be visible rather than hidden. If a dataset is too large to scan fully, you might sample it, but you should note that you sampled and what that implies. If certain logs are inaccessible, you should record that as an access issue, not as an assumption that the logs are safe. A consistent record turns discovery into a living process instead of a one-time project. It also creates continuity, so the next person can repeat the same search without starting from zero. A common misconception is that sensitive data discovery is only a technical task, like running a scan and accepting the output. In reality, discovery is a conversation between the system's behavior and the organization's definitions, because sensitivity depends on purpose and risk. A student database in a school environment might have different sensitivity categories than a shopping site, even if both store names and emails. The same is true for logs, where some identifiers might be fine to retain for troubleshooting while others are excessive. Consistent discovery requires aligning the technical signals you scan for with the practical meaning of the data in that environment. That does not mean you need committee meetings to begin. It means you need clear categories and stable rules for what you treat as sensitive. When the rules are stable, the discovery process becomes stable, and stability is what makes it defensible. One more misconception is believing that metadata is always safe because it is not the file content, or that logs are safe because they are internal. Attackers love internal data sources because they often have weaker controls and broader access. Metadata is frequently exposed to systems that need to list or index objects, which can create large blast radius if those systems are compromised. Logs are often readable by many teams and copied into central stores, which can turn one mistake into many exposures. Consistent discovery means you do not give these sources a free pass just because they are not the primary database. You treat every copy and every description of data as part of the data itself because it can reveal enough to cause harm. That mindset is one of the biggest upgrades a beginner can make because it replaces assumptions with verification. Putting this all together, the consistent way to find sensitive data is to repeatedly apply the same mental model across storage, databases, logs, and metadata, while expecting sprawl and transformations. You identify the containers, you define the signals, and you scan for those signals with validation that avoids unnecessary exposure. You remember that structured systems like databases still contain messy fields and shadow copies, and unstructured systems like storage still have patterns and context clues you can use. You remember that logs are not just messages. They are recorded interactions, and recorded interactions can include sensitive content. You remember that metadata can carry sensitive values and can also act as a map to the most valuable objects. When you keep those ideas together, you stop relying on memory and start relying on a repeatable discovery habit that holds up as systems evolve.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.